Please get out your note sheet for 6-3 solving systems using elimination, addition, and subtraction.
Alright, so far we've looked at solving systems using graphing and substitution. We're going to start looking at elimination, and we'll focus first on elimination with addition and subtraction, and then we'll look at ones where you can eliminate other ways. And elimination is easiest to use when the equations are already in standard form, and then a couple of other things that we'll look at here in a second. So we'll start with basically what does elimination mean, and if you understand what elimination means, it'll make sense to the math that we're doing to solve these. So elimination is getting rid of something. And so when we focus on elimination with systems, we're going to use algebra in order to get rid of one of the variables so that we can solve the equation for the remaining variable. You don't have to write that second bullet down or anything, but that's just kind of showing what our goal is. So use elimination to get rid of one of the variables. Remember, a systems of equations has an x and a y, so we're going to try and get rid of the x's or get rid of the y's so that we can solve our regular equation. So your steps for using elimination are as follows. Step 1 is to put the equations in standard form. And standard form will look like this. ax plus by equals c. And a, b, and c really just represent different numbers that are going to be in the problem. The x and the y will always be the variables, but a, b, and c can be replaced with any numbers that problem just tends to have. Step 2 would be to determine which variable you want to eliminate. And what you're going to want to do for that is look at the variables and find the ones that have the same coefficient. So if they have the same coefficient, we know we can get rid of that by either adding or subtracting. Step 3 is to either add or subtract the equations. And again, that's going to depend on if adding will get rid of the variable or if subtracting will. And then after, you're going to solve for the remaining variable. So if you've eliminated x, you're going to have just y's left over, so you would solve for y. Once you solve for y, we're going to move to step 4, and that's going to basically be solve for the other variable. So if we know y, we now need to plug in and solve for x. So we would substitute the value of y solved back into one of the original equations, and then that way we can solve for our opposite variable, which would be x if we were solving a system for y first. Step 5. Obvious because it's an equation, check your solution, and when you check, you're going to substitute your ordered pair back into both of the equations to make sure that it works. Honestly, these steps probably make it seem a lot more confusing than it is, so when we start looking at examples, it should make a lot more sense, but these are still a nice go-to to just kind of remind you of what you need to think through whenever you're solving. So this one is not on your note sheet, so I just want you guys to watch and see how this works. And I have the steps on the side to kind of remind us. So it says put the equations in standard form. Well, that's already done here, so we don't have to do that. Step 2 says to determine which variable you want to eliminate, and we're going to know by looking at which one of the variables, the x's or the y's, have the same coefficient. So I've got 1x plus 1y, and then 3x minus 1y, and the ones that have the same coefficient are these y's right here. So I'm going to go ahead and eliminate those y's, and I would move to step 3. I would say if I add these two equations, is that going to eliminate, or if I subtract, would that eliminate? Well, because I already have a positive 1y and then a negative 1y, I know I can basically say, hey, let me just add the entire top equation with the bottom equation, and that will make these go away because 1 plus negative 1 goes away. It's kind of like combining like terms when you do the adding or subtracting. So then we've got 1x plus 3x, which is 4x, and 7 plus 5 is 12. And then we're going to solve for x. X would be 3. Once I know x, I'm going to be able to plug that back in to solve for y. So I'm going to pick that top equation because it looks easier. And if x is 3, then I'm saying 3 plus what is 5, and y would be 2. So that means my solution for this system is 3, 2. And if I want to check it, in the top equation I'm saying is 3 plus 2, 5. And in the bottom equation I'm saying is 3 times 3 minus 2, 7. And I know 3 plus 2 is 5, and then I know 9 minus 2 is 7. So my check works for both. So I know 3, 2 is definitely the answer to this. So this is your first example on your note sheet. So again, we're going to go through these steps. Step 1 is already done, standard form. Step 2 is look for the variable with the same coefficient so we can eliminate it. And I actually have kind of an issue here because the x's both have 5s, well 5 and -5, and the y's are both the same coefficient of 2. So this problem you can actually decide if you want to get rid of x or y, and it's going to depend on if you want to add or subtract. And I would definitely say adding is easier than subtracting. So if I'm thinking of adding -5 plus 5, that's going to create a 0. So I'm going to add every different part of this. So I'm going to add the 2y plus 2y to give me 4y. -11 plus -1 is -12. And then I'll divide by 4. And then y would equal -3. So again, once I know y, I'm going to have to solve for x. So I'm going to plug this back into one of the top equations. And I always just say pick the one you think looks easier. To me, the bottom one looks easier. The top would give us the same answer if we math right. So if I plug it into the bottom, I'm going to go ahead and add over my 6, which is going to give me 5, and x should be 1 here. So my final solution, which means if I graph these, they should intersect at the point 1, -3. And if I want to check those, yes, you can kind of graph it to check it, but I'm going to do this algebraically without a graph by plugging it into the equations and checking. So you can see my checks over on the side. In the top equation, you do end up with -11. In the bottom equation, you do end up with -1. So you know for a fact that's the right solution to this problem. All right, so example 2, again, they're in standard form, so we're going to look at what to eliminate based off the coefficients, and the coefficients that are the same right now is the 4 and 4. However, if I'm thinking of adding to make these 4's go away, 4 plus 4 is 8, so I'm going to have to use subtraction here. The trick with subtraction is that you're not just subtracting the x's here, you have to subtract the entire bottom equation, which means you're going to end up distributing that negative to everything here, and that's the biggest thing people would make a mistake on. So you can either say to yourself 4x minus 4x, great, that's gone. But then this becomes 1 minus -2, and that's really like a 1 plus 2. So that would end up becoming a 3y. And then 7 minus -2 really becomes 7 plus 2, which is 9. And then we can solve for y and get 3. So the hardest thing of subtraction is making sure you're distributing your negative to the entire equation that you're subtracting, not just a part of it. So once we have y, we can solve for x. Top one looks easier to me. And we're going to subtract 3. So we get 4x equals 4. X would be 1. So again, according to this, if we're right, this is where these two lines would intersect if we graph them, which means 1, 3 is the only thing that should make this true. So I'm going to go ahead and do my check. So again, if you check into both equations, you can see on the side here that they do work. So we know for a fact that's our answer. Okay, number 3 is kind of already almost set up to be a substitution, but we can make it work for elimination if you'd like this better. We just have to do step 1 this time, which is get standard form. Standard form means the x's and y's have to be on the same side. So if I want this top equation to be standard form, I have to add over my 2x to get to the other side so it's with the y. So that should give you 2x plus y equals 7. And then the bottom equation is already good to go. So now we're going to look at which to eliminate. And I can see that the y's right now have the same coefficient of 1. Now I'm saying if I add, will that make them go away? Well, no, because 1 plus 1 is 2. So I'm going to have to use subtraction again. And when I subtract again, you have to subtract everything. So this is 2 minus 4, which is -2x. 1 minus 1 is gone. And then 7 minus 5 is 2. So then we solve for x, and x should be -1. We're going to plug that in and solve for y. And that first top equation is really easy to solve for y. So y is just 7 minus 2 times -1, which becomes 7 plus 2, or 9. So again, according to this, it looks like my solution and point of intersection is -1, 9. But if I want to check it, I'm going to plug them in and see if it works. And again, you can see the check over on the side that it does work out, that the top and bottom equations are true with that ordered pair, -1, 9. So example 4, I have a multiple choice up here. Nice thing about multiple choice is you can always plug in these and see which ones work. But this one's actually a pretty easy one just to start solving. So I see that my y's already have the same coefficient, and because they're opposite signs, I can use addition to eliminate because -3 plus 3 is gone. So then 2x plus x is 3x, and then -2 plus 17 is 15. So then x is 5. So right now I can get rid of anything here where x is not 5. So then I know y is either going to be 3 or 4 according to this as multiple choice. So at that point you could just plug in a 3 or a 4 for y and see what works, or just solve by plugging in your x and solving for y. And it looks like y should be 4. All right, 5, 6, and 7, if you want to pause and try these on your own, I'll give all of the answers in a second. Or if you think you need to walk through them, just hang on a second. But for number 5, you should be eliminating the y's. And since they already have opposite signs, we can use addition for that one to eliminate. For number 6, we should be eliminating the y's again because they have the same coefficient, but they're the same sign, so you're going to need to use subtraction for 6. And then for 7, you would have to do standard form first. And then once you do standard form, you'll be able to pick if you want to eliminate x and y, since they're all going to be coefficients of 1, so whatever you think is easier. So go ahead and try these, and then when you're ready, you can press play. All right, so number 5, final answer should be 2, 1. And I used, again, addition, so you should end up with x first, and x is 2. Plugging that in, y should be 1, and then the checks are shown at the very bottom. Number 6, when you use subtraction, that's going to become 4 minus negative 3, which is really 4 plus 3, so that's 7x. The 5s will cancel when you subtract, and then 4 minus negative 3 again is 7, so you end up with x is 1 and y is 0. And again, the checks are showing you that it does work out at the bottom. And then number 7, so the top equation in standard form, you have to move the x to become x plus y equals 8. The bottom, you move the y, so then you have x minus y equals 4. Now, you could have technically eliminated the x's first by subtracting, but again, I prefer using addition if I can, so I know the y's will eliminate with addition. So if you want that, you would end up with 2x equals 12, and x is 6, and then y would be 2. And the checks, again, show that that does work for each of those. So hopefully it's starting to make more sense. We're just looking to add the two equations to eliminate a variable so we can solve for one variable and then plug it in to solve for the other. All right, and number 8 is a nice little word problem here, and it says find two numbers whose sum is 18 and whose difference is 22. So since we don't know the numbers and they're not the same, we can't call them the same variable, so we have to assign each of these numbers a different variable, and we'll just use x and y. And the two equations we're going to get is one equation showing that when you add these two numbers, like x and y, you're going to add and get the sum of 18, but when you take these same two numbers and subtract them, the sum, or the difference, sorry, is 22. So from there you can use your elimination method, and I know I can get rid of the y's by adding, which would give me 2x equals 40, and x would be 20. And then whenever I want y, I'm just going to plug that in. So I'll do the top equation, and it looks like y was going to end up being negative 2. Now, because this one was multiple choice, you could have just looked at all 4 answers and added them and subtracted them to see which one works. But if you don't have multiple choice, this would be how you would do it. Write your equations, solve, and check. All right, and then the last 4 problems are just making sure you're 100% good to go on these. So if you want to go ahead and try these 4, and then you can just press play whenever you're ready to check your. All right, so number 1 should be 2, negative 3. And you can use addition to eliminate the y's, and you get x is 2, and then plug it in to get y is negative 3. Number 2, you can eliminate the y's by adding, so you end up with 12x equals 12, and x is 1, and then solving for y is also 1. Number 3, you can use addition to eliminate your y's again, so you end up with x is 2, and then plug that in, and y should be negative 10. And then number 4, hopefully you were able to figure this one out. So when you use subtraction, because we have to use subtraction to get rid of either x or y, the x's and the y's all cancel. So that's going to leave you with just nothing on the left, so it's 0. And then 9 minus 5 is 4. So we're left with 0 equals 4, and that's definitely not true, so this would be no solution. Now, if we were left with something like 0 equals 0, because that is true, that would be an infinite many solutions. And if you actually solve these two for y to think of the graphs, they would have the same slope but different y-intercepts, which means they're parallel lines, and that's why this is a no solution. So algebraically, this is how a no solution will work out. If we graphed it, they would just be the same slopes and different y-intercepts. So that is it. Hopefully this made sense. I know it's weird and different, but this is actually my favorite method, so we will practice a little bit more and then look at the other method for elimination in class. And if you guys draw a star in the bottom right corner of your note sheet, you will get extra credit points for paying attention and actually listening to the whole video. So please don't tell anybody else, and I will see y'all soon.